Hi, in this video we are going to implement the getMax and getMin functions. We have been discussing that basically in a binary search tree, the left subtree is always smaller than the given root and the right subtree is always greater than the given root. What does it mean? It means that if we would like to get the maximum value, we just have to go to the right as far as possible. If we would like to get the minimum value, we just have to consider the left subtree as far as possible. Okay, so whenever I'm going to create a helper method, so public t, for example, get min value, and we just have to check first that if the root is equal to null, which means that the binary search tree is empty, of course we just have to return null. And anyways, we just have to call this getMin function and it's going to return this value. So okay, I'm going to get rid of this first of all. It's going to have a parameter, sorry for that, a node. Okay, and we are going to set the root node here. So we would like to get the minimum and the starting node or the starting vertex is going to be the root node. So we have to modify it. It's going to get a node parameter node, and I would like to do the same for the getMin as well. Let's save it. Okay, what's the problem? That it's going to get a node as well. As far as getMin is concerned, we just have to go to the left as far as possible. So we just check if the node.getLeftChild is not equal to null. What do we have to do? We just have to call this method recursively on the left subtree. So we just have to return with the getMin, and we just have to specify the node.getLeftChild. Okay, and anyways, we know for certain that we are standing at a node that's left child is equal to null. Then we are going to skip this and we are just going to return with the node.getData. Okay, so this is how we implement this getMin functionality. And the getMax is going to be approximately the same. We start at the root node. If we come to the conclusion that the getRight, it's very important that the right subtree is the greater one and we are looking for the maximum item. So if the getRightChild is not equal to a null, then we just have to call this method. So return with the getMax, but we just have to delegate the getRightChild. So we call this method recursively on the right subtree. Anyways, we know for certain that this getRightChild is null. Then basically this code is going to run and we are standing at the node that's the rightmost. So it is the greatest one. So we just have to get the data. Okay, so that's all about the getMin and the getMax methods. Let's see whether it's working fine or not. I'm just going to create a binary tree. I'm going to get rid of these. And I'm just going to instantiate, for example, integers. It's going to be the binary search tree, BST, is equal to a new binary search tree. I would like to insert several, okay, not the insert data. Sorry, maybe we would like to make it private in order not to be able to call it from the outside, whatever. I would like to call the binary search tree insert method. What's the problem? Insert method. Okay, and we won't be able to call it because the tree does not specify this method. So maybe I'm going to make the tree has the insert method. It's just going to get the data. And sorry for that, it's just going to get the data like this. And basically in the binary search tree, we are going to get rid of this override. We are going to make it private. We don't want to be called it from the outside. Okay, we have this insert method and it's going to be the override, which means that we have defined it in the tree interface. And we would like to make the same for this one. So in the tree, we would like to get the getMin value, for example. So get min value, which is not going to get any parameters. And get max value, again, it's not going to get a node. I'm just going to save it. And the binary search tree, we just have to make this override annotation, and we have to make the override annotation for the get max value. So public t get max value. Again, we have to check whether if the root is equal to a null, then we are just going to return null. Anyways, we are just going to return the get max value. Okay, and sorry for that, get max. And we have to specify the root node, I think. Okay, and again, it's going to be the override annotation. And here we just have to get rid of the override annotations. And we just have to make these methods private. And private for the get min. Sorry for that, okay. So we have a helper method, and this private method cannot be called from the outside. So now we are able to call this insert method. And I would like to insert, for example, -1, then 1, then 0, then I would like to insert, for example, 1000 and -22. Okay, then I would like to print out the bst.getMaxValue. Let's save it and let's run it. It is the 1000. Okay, we have managed to find the greatest item in the binary search tree. What about the minimum value? It's going to be the -22, or at least it should be the result. Okay. So far, we have managed to create the insert method, so we basically construct the binary search tree, and we are able to get the maximum and get the minimum values. In the next video, we are going to implement the in-order traversal, which is going to yield the numerical ordering for integers. So basically, this is how we are able to sort the binary search tree. Thanks for watching.